the basic element entry. And on the top, as you know, we have these menus, and we'll be talking about the steel and the concrete menus and the analysis and design menus today mostly. So if we come to the steel menu, you have over here your basic frame element entry commands. And you might be thinking that in normal typical analysis programs, you have basically one command to enter frame elements. You basically select 2 points and you keep entering your elements. But in Comosys, you've got 1, 2, 3, 4, 5, 6, 7 commands to enter, and there are actually even more beam groups. These are all beam groups, by the way. So there's a column beam group, there's a beam group, this is a horizontal bracing group, there's a vertical bracing group, truss group, purlin groups, and there are other groups as well. But the reason why we have these over here is because we want to automatically facilitate filtering and some other technologies which we've discussed in the other webinars, like IntelliConnect and this and that. Now, so coming back to the analysis part over here, to enter elements, all of these commands basically work by selecting 2 points, except for the column, which works by selecting a single point. So if I were to select this column command and press any point, click on any point, immediately a column is created. It doesn't require 2 points. The reason why it doesn't require 2 points is because it takes the current work plane Z direction as the direction of the column, and the length of the column depends on if I double click on this column right now, then there's a parameter over here. This is the point which I selected. How much does it want the column to go below that point, and how much does it want the column to go above that point? So these two numbers basically define the exact position of the column. And like I said, this direction comes from the Z axis of the current work plane. So if I were to, for example, enter 1000 over there, it will extend the column 1 meter below the point I selected. And you can choose according to whatever your needs are. So now let me quickly enter a few more columns using the same command which we just talked about, and then go to the beam command. And then basically this one takes 2 points rather than a single one like the column. And we can basically create some beams on the screen. Now, as you can see on the screen, I have immediately started benefiting from using different commands for each beam group. So not only are the beams of a different color, and visually I can immediately tell which ones are the beams and which ones are the columns, but if I were to make a general selection and press enter, I can even see that beam grouping over here. So if I wanted to select only the beams, I could just double click on the beams and only the beams would then get selected. Now, if the benefits of that automatic grouping weren't clear in the simple case which I just did, let me just show the same thing to you in this large preheater model. Let me just go and select randomly like that. But what if I wanted to select only the horizontal bracings on the floors? I would just press enter, go to my profiles and group by beam group, and I say I want the horizontal braces only, and immediately my horizontal braces would have gotten selected. This could be further refined into just what a particular section or the beam group, but the point I'm trying to make over here is that this automatic grouping by beam groups is extremely beneficial, and I would recommend that you never, what you can do is, for example, use the beam command to enter the entire building. You can do that. There's nothing stopping you from doing that. But make it a habit to, in Comosys, to always use the different commands which we have over here for the beam groups. The reason why they're grayed out right now is because the model is locked, because this is an analysis model. But the point is that you always use the relevant command, which if you're entering a vertical bracing, use the vertical bracing command. If you're entering a horizontal bracing, use that, a truss, a purlin, a girth, depending on your need. Now, coming back to our small building, let's add a few more beams. So let me just go from here to here, from here to here. As you can see, I've just snapped to the midpoints of these existing beams, and so what we have over here are the snap options, and if I turn them on, you can see that the midpoint has been turned on, and you've got other things like control points, intersection points, perpendicular to, perpendicular from, parallel, etc. Different options are available. But when we say midpoint, what we mean is the midpoint of a segment, actually. So this was the original beam, and when I was entering this beam, I was snapping to the midpoint of this original beam, and I went from there to there. But now if I go to the beam command again, I come over here, there's another midpoint which comes up, and this is now the midpoint of this section of the beam. So what midpoint will basically tell you is that it is always the midpoint of the segment. So I can go like that, I can go from here, and this one will snap perpendicular, it's also the midpoint, and I can go from here to here, and it will snap from the middle of there to the perpendicular point at the other side. Now, one thing which I want to say is that if I zoom in there, for example, and I wanted to enter a plate, just like you can see that I can snap to any one of these points like that. All those are snappable points. But if I were to enter a beam, then those points it doesn't snap to those points, because it wants me to snap to the finite element endpoints rather than, because I could be very far, I could be working from this zoom level, and I could just go in there and say, okay, I want an element from there to there, and accidentally I could have chosen maybe this point when I was doing that. So by default, Comosys will not allow you to snap to these definition points, or rather not to the definition points. We call them control points of the members, but it will force you to snap to the definition points. Now, of course, you can override these options and you can snap any way you want if you needed to. But the good thing is that it will not allow you to make mistakes like that unknowingly. Now, since we're talking about finite elements today and analysis and design, we have to talk about nodes or joints as we call them in Comosys. Now, in Comosys, you don't create nodes separately and then connect elements to them. As you create your elements, your nodes are being created automatically. So if I were to zoom in there, you see this yellow dot over there, this one, which you can select. That's a finite element node. And you have the visibility and selectability of that over here. So if I can turn them off, I can turn them back on. But the moment you create any element, so let me create a column, for example, over here. Immediately, if the nodes at the two ends are also created with it. So there's one over there, and there's one, if I were to turn it around, there's one over there as well. Now, the thing about these nodes is that they're of two types. One what we call end nodes, and one what we call intermediate nodes. If the node is an end node, it will be yellow. So this one over here, for example, was created when we created the column. But then when we entered the beams, the beams did not create extra nodes over there. So they're not three nodes over there. Only when the first column was entered was a node created. When the beam was entered, it automatically, the program noticed that the node already exists at that point. So I don't need to create a new one. So I just use the old one, and the same for this one. So if I were to double click on this node, you will see that it says it has a number of connected frames to be 3. If I were to double click on the column I just created over there, you will see that the connectivity will be just 1. Or if I were to, for example, create a beam from there to there and zoom in again, and now double click on this one, now it's turned into 2. So the connectivity keeps changing as you keep entering new elements. Now, I was mentioning that there are two types of nodes. One is the yellow one, which we call the end nodes. And what we mean by that is that if a node is yellow, what it means is that all the elements, so the connectivity is 3, which means 3 elements are framing into that node. But the fact that it's yellow is telling me that all the elements are the end. It is the end of all the elements framing into it. So it's the column end over there. The beam ends at the same point, and the other beam ends or starts at the same point, basically. But these nodes can also be blue. So, for example, the same node over here is blue, and this one has a connectivity of 2. which means that there are two elements. One is this one, this continuous one, and this beam framing into it. Now, the fact that it is blue is telling me that this is not an end node, but it is an intermediate node. And what that means is that from the connectivity of whatever 2 or 3 or 4, from that connectivity count, one member is continuous and the others are ending at that point. So in this case, the one member which is continuous is this beam, and the others might be. So if I had another beam, for example, from here to here, now if I double clicked on that, the connectivity would be 3, but still the same one, this one would be the one continuous one, and the other two would have to be end points. So if one of the elements is continuous, the node will turn blue. But if all are ending or starting at the same point or at that point, then the element will be yellow. Now, what you're not allowed to do is something like this. So, for example, if I were to say, let me find an example over here. Yeah, maybe I can do something like this. I can create a beam from here to here. Now, this one actually is going through this point over here, but there's another one going through this point as well. So you can't have two elements which are continuous at the same point. If you have that situation, you have to find another solution. You have to break that element at that point and re-enter it from the other side. Now, that might seem obvious. It makes sense that you shouldn't have two continuous elements going through the same point. Obviously, there'll be a huge clash. But in steel detailing, you can have situations like this. So, for example, if I were to go to this to the midpoint from there to there, and instead of putting that to be behind, if I entered it like that, now this could be a valid real situation in which this beam is sitting on top of these beams, and in this case over here, one beam is going over. So at this point, there is a continuity in both the elements. And if I were to go to my finite element model, which I can do by pressing Alt D for example, a couple of times, I can see the line mode. You can see that this line is continuous as well as this line is continuous, but no node is formed over there because right now they're oblivious to the existence of each other. They don't know. This one doesn't know this one is crossing over me, because only one node can be continuous. And if you have a situation like this, what you would need to do is you would need to actually slightly raise this and give it an offset and then connect it so that then have these little connection elements between the two, and those connection elements will then create the relevant nodes. Right now, if you do the analysis, this one and this one will not have this contact at this point. Another thing which I can mention over here is these little green dots which you're seeing on the screen. They represent internal releases. So if the element has any release, so for example, if you're talking about this beam has a start and an end, and we can see that there is some release at the start and there is some release at the end. Now, what release that is, we don't know. We have to double click the element and go to the analysis tab over there. And there we see that the start has moment M22 and M33 releases, and the end has M22 and M33 releases. But even if it had some other release, as long as there was one release, you would see this green dot. And there's a toggle, especially created in Comosys, because in steel, it's extremely common to have these M22 and M33 releases at the ends. So we have a toggle called Control R, which we can then do to remove those M22 and M33 releases. And this is very commonly used in steel. Now, it's a good practice to remember this blue and yellow color coding, that the blue ones are intermediate ones and the yellow ones are end ones. Because if I make a mistake in snapping, that can remind me of my mistake or correct me when I make that mistake. So let's say I was entering a beam from here and I wanted to snap over here, but forever I'm going to make the mistake deliberately over here. Instead of snapping to that point, if I just press enter and I say dx1, which is just 1 millimeter away in the x direction, and I create a beam. Now, it seems as if, because from this distance, it seems as if everything is okay. But immediately, the presence of this yellow node will tell me something is wrong, because this one is continuous. And had I properly connected to this one, this should have turned blue. But since I snapped to about 1 millimeter away from that, it's actually yellow right now. And if I were to go into the plan view and turn on my finite element mode and I zoom in, I will soon see that actually I'm not touching that element. Now, one thing which needs mentioning at this point is that if you were entering a concrete building, for instance, and you were in this menu, and these are the commands which we typically use to enter the main parts of the building, and then we have some more on the side. But what I want to mention at this point is that only the beams and the column commands will actually create a finite element model. For example, if I were to create a slab over here right now, this will not convert into a finite element model. This does not mean that this is a shell element which will get converted during the analysis stage. Or if I were to create a wall between these two columns, this does not mean that this is a shear wall. Both these elements are merely for detailing purposes. You can do anything. You can create flares in them. You can modify their geometries any way you want. The primary purpose is for detailing. If you did actually want to convert them into a finite element model, we will talk about that. There's a different command for that, which we call supershells, and they're very nice tools where you can convert any shell or any slab or any wall into a supershell. But that's a separate thing which you would need to do. At this point, what I would like to mention is that merely seeing a slab or a wall over there should not tell you that this will become part of the finite element model.